Every developer who uses AI coding assistants hits the same wall. You know what you want to fix. You can see it right there on the screen. But turning that visual thing, that button, that broken drop-down, that misaligned card into a prompt that actually gets a useful answer? That takes 5 minutes of careful writing. And most of the time, you still get a generic response. DOMPrompter cuts that entire step out. You click the element. It writes the prompt for you. Here is what actually happens. You install DOMPrompter as a browser extension or inject it into your dev environment. You open the page you are working on. You click any element in the UI, an app bar, a form field, a modal. DOMPrompter immediately inspects that element in the DOM, pulls its tag, its CSS classes, its ID, its position in the component hierarchy, its computed styles, any event listeners attached to it. Then it assembles all of that into a structured coding prompt. Not a vague description. A structured prompt, formatted to give an AI assistant, Claude, GPT-4, Cursor, whatever you use, the exact context it needs to give you a precise, actionable answer. The output looks something like this. Component type, button. Selector, .btn primary inside nav parent, header component. Current behavior, no response on mobile tap. Expected behavior, triggers drop-down menu. Framework detected, React. That structured block, dropped straight into your AI assistant, consistently produces better answers than a paragraph you wrote from scratch. Because the AI is not guessing at your stack. It already knows. What surprised me was the selector accuracy. On a moderately complex React app with nested components and dynamically generated class names, DOMPrompter still produced a usable, specific selector almost every time. That is not trivial. If you have ever tried to manually write a CSS selector for a deeply nested component built with a CSS-in.js library, you know how fast that gets painful. But here is the thing, there is a ceiling on what this tool can do, and it is worth being honest about where that ceiling is. DOMPrompter reads the DOM. That is its entire surface area. It does not read your component source files. It does not know your prop structure. It does not know the business logic behind why that button does what it does. If the bug is in state management 3 layers up from the element you clicked, the prompt it generates will point your AI assistant at the wrong place. You will get a technically accurate description of the element and a completely wrong diagnosis of the problem. It also does not work well with server-rendered content that gets high-graded after load, or with canvas-based UIs, or with anything that does not live in the actual DOM. Think embedded maps, WebGL components, chart libraries that render to canvas. Click those and you get a prompt about a canvas tag. Not useful. And there is a workflow assumption baked in that may not fit your setup. DOMPrompter assumes you copy the prompt and paste it into your AI assistant manually. There is no direct integration with Cursor, no VS Code extension that auto-inserts the prompt, no API. The handoff is still manual. For a tool that promises to remove friction, that last step can feel like a speed bump. Now, where could this realistically go? The most obvious evolution is IDE integration. If DOMPrompter could send the generated prompt directly into Cursor or Copilot chat as an inline context block without leaving the browser, that removes the last friction point and makes this feel like a native part of the development loop. That is buildable today. The browser extension API and the VS Code extension API both support the pieces you would need. A second direction that makes sense, component level awareness. Right now it reads the rendered DOM. But in a React or Vue project, the element in the DOM maps to a specific component file. If the extension could resolve that mapping using source maps or a companion dev server plugin, it could include the actual component name and file path in the prompt. That would make the output dramatically more useful for debugging, not just styling. A third possibility is team templates. Different teams prompt AI assistants differently. A template layer, where your team defines the structure and fields of every generated prompt, would make DOMPrompter a shared workflow tool, not just a personal shortcut. So why does this exist? Because prompt engineering for UI work is genuinely tedious, and the gap between what you see and what you can describe to an AI is larger than it should be. the DOM already contains most of the information you need. Your browser already knows the selector, the hierarchy, the attributes. DOMPrompter is the observation that this information is sitting there and used, and that a structured prompt built from live DOM data should almost always outperform one written from memory. The honest verdict: this is a sharp tool for a specific slice of the workflow. If you spend significant time asking AI assistants to fix or style specific UI elements, DOMPrompter removes a real bottleneck. It is not a replacement for understanding your codebase, and it will not help you debug logic that does not surface in the DOM. But for the thing it does, turning a click into a structured, context-rich prompt, it does that well. Next episode, we are looking at a tool that goes one layer deeper. It does not just read your DOM, it watches it change over time and flags the components that behave inconsistently across sessions. If flaky UI bugs have ever cost you a day, you will want to see that one.